Hey, 8th grade, you guys are doing awesome. I've been checking your work and the text that you're sending me, and you are doing great. So keep it up. Today we are moving on to angles and triangles, how to solve for an unknown angle or an unknown side. So let's look at what an angle is. What is an angle? An angle is made up of two rays that have a common endpoint. So here we have intersecting lines. These actually form right angles because all of these measure up to be 90 degrees. The angles measure to be 90 degrees. Okay, so these are all examples of angles. Let's look at angles within a triangle though. So the angles of a triangle, so these are the angles right here, okay? The angles of each triangle should add up to be 180 degrees. So here we have a triangle that has 60 degrees for each angle. This would be called an equiangular triangle because they all have the exact same measurement. When we add 60 plus 60 plus 60, we get 180 degrees, okay? Let's look at one that has a right angle in it. So this triangle has a right angle right here. So even though it doesn't tell me that this angle is 90 degrees, I can tell right off the bat because it has that little square right there in the angle. So that tells me that this is a right angle, 90 degrees. So I have 60 and 30. 60 plus 30 is 90 plus 90, which would give me 180. Let's look at this one though. When we have a missing angle, we know that all of the angles must add up to be 180 degrees. So we have an angle that measures 135 degrees. That's an obtuse angle. Okay, and then we have an angle that measures 25 degrees. So if we add those two together, we get 160, okay? We know that all of our angles in a triangle must add up to be 180 degrees. So we're gonna take 180 degrees and subtract 160. And that's gonna give us what that missing angle is. It's gonna be 20 degrees, okay? So this angle right here would measure 20 degrees. Okay, so in a right triangle, so let's specifically talk about right triangles now. In right triangles, we have, let's look at the outside, okay? Now we're not focusing on the angles within, let's look at the sides of the triangle. So we have two sides that are just gonna be called sides, or sometimes you'll see them referred to as legs. Okay, we have, they share a right angle on the inside, okay? Directly across from wherever the right angle is, we have the longest side of the right triangle. This is called the hypotenuse, okay? So let's look at how we would solve for missing sides or solve for the hypotenuse. Okay, so now let's look at how to solve for the sides of a triangle. So we're going to use a formula called the Pythagorean theorem, which is the formula is a squared plus b squared equals c squared. So a and b are going to represent the sides of the triangle, and then the hypotenuse is going to represent the c. So if we square the sides, okay, and add them together, then it should equal the side of the hypotenuse squared. So let's look at what this formula would look like, okay? So we have been given the sides of this triangle right here. We know that this triangle, this side would be 6 units, and then the base is going to be 8 units. So we are missing our longest side of this triangle, the hypotenuse. So I'm going to plug this into the formula. It doesn't matter which one of these is A or B, okay? They're both sides, okay? So I can plug them in for A or B. So I'm going to put 8 is going to be my A, so I'm going to square it, B squared, so 6 is going to be squared. And then that should equal this longest side, this C. So 8 squared is going to give us 64. 6 squared is going to be 36. And then we still have our missing side there for the C. We're missing the hypotenuse. So if we add 64 plus 36, we will get 100. And then if we find the square root of both sides, we will end up with our missing side, which is 10. Good? Okay. Now let's look at one if we that's a little bit different. So this time we have been given the hypotenuse, so we have the C, but we are missing either the A or the B. We're missing one of the sides, okay? So I'm going to still use the same formula. I'm using A squared plus B squared equals C squared. So I have plugged in the 3 for the A, okay, plus B squared, because that is what we're missing. We're missing one of the sides, equals our C squared, okay, which is this side that's measuring 5 units. So 3 squared is going to give us 9. I'm going to keep that B squared right there because that's still what we're missing, equals, and then 5 squared is going to give you 25. Now I'm going to combine my like terms, so I'm going to move this 9 over to the other side of the equation. When we do that, we're going to be subtracting it. So 25 minus 9 is going to give you 16. So we have B squared equals 16. If I find the square root of both of those sides, square root of B squared is just going to be B, and the square root of 16 is going to be 4. Yesterday we talked about square roots that were similar to this, but we can't have a negative side of a triangle. So all of these are going to be positive. So we've got a positive 4 there. Okay, this one looks a little bit different. Sometimes you'll have them where they give you a different variable. That is okay. It says to find K. This missing side is what they're calling K, but we are still going to use the same formula. We're still going to use A squared plus B squared equals C squared. I know that I am missing a leg here or a side, because I know that directly across from the right angle is going to be your hypotenuse. So we have been given the hypotenuse. Okay, so we're still going to use this formula, A squared plus B squared equals C squared. So I've plugged in the 5 where A is. Okay, I'm going to plug in the K for B. Same thing, just a different variable, okay? So we've got 5 squared plus K squared equals the square root of 61 squared, okay? When I square the square root of 61, I end up with just 61 because those two are going to cancel out. 5 squared is going to give you 25. Now I'm going to combine I'm going to move this 25 over to the other side. When we subtract 25 from this side, we must also do the same to the other side of the equation. So 61 minus 25 will give you 36. And then we find the square root of both sides. So the square root of K squared is going to just give us K. The square root of 36 is going to give you 6. Okay, and we know it's going to be positive. Okay. Okay, so the last thing we're going to look at is called Pythagorean triples. So I'm going to use the same triangle that we had earlier. We have solved for this missing side. We know that it is 4. So this side is 3, this side is 4 units, and the hypotenuse is 5. So the way you can write this out, we call these Pythagorean triples. You can write the sides in ascending order. So you write the smallest first, so 3, 4, and 5, just like that. Easy peasy. Okay. We can also find triangles that are similar to by multiplying each side by the same thing. So if I multiplied all of these sides by 2, I would come up with a similar triangle, which would be 5 times 2 is 10, so the hypotenuse of this one would be 10. And then 4 times 2 would give us 8, and then our base would be a 6, okay? So what I would like for you to do, this should not take you long at all, maybe just a few minutes. I would like for you to do on page 411, you're going to do problems 8 through 13. And please, please, please don't hesitate to reach out if you have any questions. Just send me a picture, and so that way I can see that you're on the right track. Okay, you guys are doing awesome, and I'll see you in the next video.